Hello and welcome to another F12 video. My name is Mike Hewitt.
I'm Jacob Rains.
And today, the last video we were talking about variables. In this video we're going to be talking about a couple different things.
A little bit of housekeeping.
A little bit of housekeeping, ifs and fors and stuff like that. But go ahead, what are we working on?
So we've got this console app that we've been working with, which is just a really basic app. And if you watch our previous two videos, you can see us go through the real basics of installing the software and how we got here. Up until now, we have just been writing some quick little code in this program.cs file. Just for the sake of good habit making, we want to go ahead and flush this out correctly. So you see up here on line 1, we have a comment, which is starts with 2 slashes. That's a nothing line of code. It's just there for us to read as human beings. It doesn't actually change the way the program works. So let's go ahead and wipe that out.
Okay.
And just to see our starting point here, why don't we run the program and let them see what it does?
Okay.
Which right now is not much. It is a single line of code. It
says hello world.
Hello world. And that's it. That's all the program does. And it immediately ends after it prints the hello world out on the program. So there's a few things that we should do on every single piece of code, just as a matter of good practice. The first thing is we need to give it a namespace. And a namespace is just, how do I explain a namespace?
It's like a folder structure.
It's like a folder structure.
Without going too much into it.
It's basically a proper full name for it. So we're going to say namespace. We can put literally anything we want to put. And for right now, we'll just put a semicolon, Mike.
Oh, here? Okay.
Yep.
You want to do it that way?
Yeah, well, we don't have to add any extra overhead or complications. So we're going to just say namespace VS101. It just means that in this file, anytime we reference VS101, we're talking about this part of the program. It doesn't change the way the program runs in any way. It will be important later, and like I said, we're just doing it as a matter of housekeeping.
And you could see it like this, and you could see it like this, and then everything in here will go inside of that. And then...
Yeah, that's the old school way of doing it. Still very common.
This is not working because...
It's not working because we're not done yet.
We're not done yet.
Yeah, so inside of a namespace...
Yes, but when they create new program or new other files, it will, classes, it'll look like that.
True.
But we're going to go ahead for right now, we'll do it like that. Oh, I took it away. Look at that.
Yeah.
Okay, so then next,
all code has to be wrapped in what's called a class. And before, up until now, when we run this, it knows, oh, it needs a class, and it's doing it in the background for us. It's pretending like we already wrote the code. So we're going to write a class, and you don't really need to know the nuances of all the syntax here. Just know that we need one, and we will get into more detail later. So the code is just public, class, and the name, which is program. Class names almost always match the file name. And if you look over on the right-hand side in the Solutions Explorer, you can see our program, our file is called program.cs, CS being for C#. So we're going to go ahead and name our class program as well.
Okay.
And every program at some point needs a main, which is what we have here on line 5. The main just tells the program this is where we start. So we've kind of skipped over this up until now, so we could play around and learn variables and do some other stuff. But I just want to go ahead and get that done.
And in fact,
so we can start seeing the proper way of doing it.
This right here is, they've kind of done what we've done in the background. They've made this in the background, and they just said, okay, well, this is like this for every program, so we're going to just take it out. But if you are anything before .NET 6, this is what you'll see. Correct?
Yeah, as a matter of fact, if you're in an older version of Visual Studio
Yeah.
and you hit File, New, Console Program, this is what you're going to
see.
Yeah.
So that's the difference between 6 and 5, is they've kind of taken some of them. I mean, there's other things, but they've taken it out.
But once we're doing anything more than just the basic, simplest of programs, we need to put it back in anyhow.
And as you can tell, it worked just like it was. Okay?
So a lot of times we call that in programmers, they'll refer to it as ceremony.
Yeah.
It's those little nuanced things we have to go through to make the compiler happy to do it the right way. And it is the right way to do it. And later on, when we have multiple classes and things start getting overcomplicated with multiple namespaces and functions and methods and subroutines, and later on it'll help that we've done it the correct way.
So I think the next real quick thing is comments. I know we saw a comment, but we can say right here easily that one way of doing a comment is 2 forward slashes, and you could tell that green color is comments. Now, of course, you could go in Visual Studio and change the different colors, but that's the default color. And we could say any kind of thing. This will return hello world. You could really say whatever you want, and this doesn't do anything for the program.
It does a lot for the programmer.
It does a lot for the programmer. Another way of doing it is if you needed a multi-line, so you can do something like this, or is it just that? And so now I can say a bunch of different things, multiple lines. If I wanted to write down a whole book, I could. There. There is some comments that you could do above here that help out, but right now we're not going to talk about that. But I do want to let you know that we will learn that down the road.
And the main thing for the comments is later when you're working with multiple programmers, I mean, they'll be very upset if you don't leave comments.
Yeah.
But even just for yourself, when you get a lot of code and you come back and you look at it 6 months later, the comments really help know what was going on. So it's important to document our code well, so that for our own benefit, if for nothing else.
And that is comments. So what else are we working on?
We wanted to get into a complicated word, flow control today.
Flow control. So actually I'm going to say this, flow control.
No water involved. So our main flow control is the if statement.
Let's do this, if statement.
So let's we talked last time about a Boolean variable. So let's go ahead and just create one.
So I'm going to create a Boolean of, oh no, running. Maybe this computer program, or or something. Something's running.
We're going to write an if statement now. What an if statement allows you to do, rather than executing all the lines of code sequentially in order, an if statement allows us to branch, to take multiple paths. So, real simple. If, this is one of the most human readable pieces of code that you'll come across. So we'll say if, and we're going to put parentheses, and inside that parentheses we have to give it a test to see if something is true or false. So we can say running equals equals true, and what the equals equals means, as opposed to a single equals, this throws off a lot of the newer programmers. An equals equals says we're doing a comparison.
Yes, this one, the one equals is putting false into here. This one is not putting true into here. What it's doing is saying so if running is true and this is true, this means it's a true statement.
That it passed the test. So whatever we put inside the curly braces, and those are curly braces, not parentheses after the if statement there. Well, to the right of the if statement is regular parentheses. Under the if statement is curly braces, which on your keyboard is shift. I type it all day long. I have no idea. It's up in the corner there.
I'm sorry.
Oh, curly braces. Shift.
Oh, it is.
They're up there by the
brackets,
backspace key.
The brackets. Yeah. Real quick, I wanted to show this. And I'm going to, nope, this needs to be B.
Yep.
If we go here. Okay, so what we're saying, if we look at A is true because 1 equals 1, and the equals is saying, is this true? Is 1 equal true? Yes. 1 is 1 equal to 2? No, they're not the same thing. So if we look at B, it's false. And that is kind of an example of that. So right here we're saying this is going to be false. So is this true? I know we have a bunch of ifs, trues, and falses, but running is false and this is true. So false does not equal true. So this statement is false. Does that make any sense?
I would say the statement fails. Maybe that make it a little easier.
It fails.
Back up on line 12 and 13, that might make a little more sense if you put parentheses in there.
Okay, like this.
Yeah. They're not required, but they help with readability.
Yeah.
So you can see now we're running a test. 1 equals 1. That's going to come back to be a true statement, and that's what's going to get stored into the A variable. 1 equals 2 is obviously false, and false is going to get stored into the B variable.
Yep.
So now, jumping back down to our if statement here, let's go ahead and say if running equals false. So it will go into the...
Okay. This?
Yeah.
I'm going to copy this.
That is exactly what I was going to suggest.
And we're going to say...
inside the if.
Is not running.
There you go.
Okay.
All right, let's give it a run.
If we do this... is not running, and then obviously it comes down here and does hello world, which we're going to say end of program.
Like it.
So is not running. There we go.
All right, now let's change up on line 10. Let's go ahead and change that to true.
Okay. And now we see end of program.
So when it hit line 16, running was true. It failed the test that the if gave it. So because it failed the test, it
never came in here.
Right, it skipped everything inside of those curly brackets.
In fact, let's go ahead and look at this. So we're here, and if I hit F10, where's it going to go? It skips over this. So it does not run this at all.
Now the next thing we can do, if we want to make this a little more complicated, we can write an else statement after the if.
There we go. Okay, and we can say is not running, is running.
There you go. And now when we run it,
is running. So it went into here rather than here.
Right. So if the if is where it goes if it passes the test.
Mm-hmm.
The else is where it goes if it fails the test.
Mm-hmm. So there's that. Do we want to talk?
There is the if else.
Yes, that's right. Okay, so let's do
or else if I mean
this.
Do you want to try something with an integer as opposed to a Boolean?
I was trying to think of an integer. Let's go back to our wonderful age. Okay, and we're going to say 0. Or let's say 20. Now, I'm going to get rid of this right here. So we're going to say...
if age less than 20, teenager?
Yes. Less than or equal to... 16. They can at least drive. How's that?
Well, you can't drive if you're 15.
Oh wait, they can. No, you're right. I'm sorry. They can't drive. There you go.
And let's take the equals off on the age less than or equal to.
Okay, that works. You're right. Okay.
Do an else if?
We're going to say they can do everything. Okay. And now here we can do else if. Okay. Oh, I'm sorry. That. And now we're going to say age. What are we going to say here?
Less than 21?
Yeah.
They can drive, but they can't drink, I'm guessing.
Yes. They can drive, but can't drink. I don't know why we're mixing driving and drinking, but but they can't drink.
They can do everything you say, but not at the same time.
Yes. But not at
our
the
public
same
service announcement for today.
time. Okay. How's that? So, what we have here is we should be going in here, correct?
I think this would be a great time to explain the console.read.
Yes. That was one other thing I wanted to do during this. How do you want to do what?
So up until now, we run the program and it just runs, and it's going to run and give you the same results every time, which is a really boring program.
Right.
We're outputting information to the screen, but what we're not doing is we're not collecting any data, which any program of any sophistication at all really needs to be able to collect information. The way we do that is we can do a console.read.
Okay.
And you can go ahead and, I think you can go ahead and do a console.write without the right line.
Console.write, like that?
Yep.
Okay.
Yep. And put a little space after the question mark.
Okay.
And then we do a console.read. Actually, read line I think requires an enter key, right?
Yes.
Yep. So let's do read line. We're going to learn all kinds of stuff here. So the read line is going to ask the user of the program to enter some information. In this case, we spit out on the screen, what is your age? Now we need to take that read line and we need to store it into a string variable.
Does that work?
Nope.
How do we do this?
It's got to be a string.
Oh, that's right.
Yeah.
Okay. Okay.
Which we talked about
That
strings
works.
in the previous video. String is characters, which makes sense because we're entering data off the keyboard. So it's expecting it to be a string. Now, this is where it gets a little weird for programmers.
Mm-hmm.
The data that's coming back that they're entering off the keyboard is going to be, ideally, should be a number like 30. You might think that that is a number, but it's not. It's a string. It is the number, the character 3 and the character 0 as text, which is not a number.
So, if I do bool, let's just say A, this will it even allow me to do that?
I wouldn't imagine that it would.
For human readables, this does not equal the same.
Yeah, the string of
The
one.
string of 1 does not equal
the integer
of 1. So, yeah, I didn't think so. But
Yeah.
For human readable, that's what we're talking about.
Yeah, the compiler just knows that that's not going to fly ever, and it's going to tell you right up front, this is never going to work.
Right.
So we get back this string of 3 and 0, or whatever they typed in. It could theoretically be a letter. We need to convert that into an integer. So in this next line, we're going to say, and I'll explain what this is here in a minute, we're going to say age, which is our variable that we created up on line 7, equals convert dot toInt32. Oh, it knows what to write already. toInt32, open parenthesis, and we're going to put that string in there.
Now, what does toInt32? I saw toInt16 and toInt64. What is why 32?
So most of the time when we deal with integers, we're dealing with 32-bit integers. So much so that anytime we say the word int, the computer just knows, oh, they mean a 32-bit integer. For the purpose of this particular command, this convert.toInt32, they put the word 32 in there, so there's no confusion.
So int64 is a big, super long number, and int16 is a very small number, but we just deal with int32 right now, and you probably won't do that until later on.
Yeah, and everything's usually optimized for int32. Occasionally you come across an int64. Int16s are rare. The only difference is the amount of memory that they take up and how big of a number they can hold. For just about anything you would reasonably encounter, an int32 is big enough. It goes up to 4 trillion before it runs out of space. So it's like a glass that can only hold so much water. An int64 would be like a pool. And an int16 would be more like a thimble. So let's run this code. And
Okay.
if you want to, let's just run it first, and then we'll step through it.
Okay. So it says, "What is your age?" What do you think?
43.
43. They can do everything, but not at the same time. End of program.
So let's just go back and look at the code and see what happened here. I think sometimes I've been doing this for a long time, so it seems pretty self-explanatory, but let me think of where things would be going awry here if I was new at this.
Yeah.
So we printed out, what is your age?
And then when it got to read line, it actually stopped the program.
Yeah, the program halted, waiting for Mike to enter a number and press the enter key.
So when I typed in 43 and hit enter, then it ran this line and put 43 into here as a string.
As in the 4 and a 3.
As in like this. Okay. Then what it did was, here the string said, okay, convert it over into an int. So it took it and converted it into this. And then when we came here, this would be 43. Is 43 less than it? No. So it's like, don't run this. Is 43 less than 21? No. And don't run this. And then it says, so we got down here, it says, so run everything else. We ran this, and then we got out and we ran that. And that is where we're at.
Now let's run it again, but this time we can put in different information.
Yes, let's go ahead. I'm going to go here and I'm going to put 15. And then it says, they can't drive, end of program. And you have to say, like, end of program.
Now we're actually getting a program that can actually do something.
Yes. So as you can see, it's this point right here, when I found this out, I'm like, oh my gosh, I started making games left and right. You want to go left, right? And it got crazy because you have to put all these if statements. But just that alone freaked me out. I was just like, oh, the amount of stuff I can do is fun. Start making games left and right. So, now, what about this? I'm an alien. I don't know what an age is, and I put the letter
I was afraid you were going to
Z.
do that.
Uh-oh.
The program stops with what's called an unhandled exception, which is a really fancy way of saying the program broke.
Yes.
So, and it gives you a specific error here. It says the input string was not in the correct format. That's fairly straightforward if you think about it. The input string, which is what we typed, was not in the correct format to be converted into a number, because there's no way to convert Z into a number.
Now we can say we can cover that later, or do we want to cover that later?
I'm trying to think of what would be the best way to cover that. You want to do a try parse?
Yeah.
So there's a function that already handles. Do I want to try parse? Yeah, let's just do it. Let's just do it. We're going to write an if statement here to basically ask if it's okay to convert it into an int first.
Okay, tell me what to type.
So we're going to do if. We're going to type the command we haven't explained yet, which is int32 with a capital I. Dot try parse. As a matter of fact, all that code that just tells you, yeah, there we go. The computer already knew where we were going.
Yep.
So this command try parse takes a string and it comes back with a true or false on if it was successfully able to convert it to a number. So
we no longer need line 20.
Yes, and we can take our entire if statement from like 22 to 33.
Okay.
And we can put it inside of this other if statement. So we can cut and paste it in there. Now what happens is when it hits line 15, where we have our new int32 try parse, parse is a fancy word for convert to the correct format. So we literally read that as try to convert it to an int32.
And this is going in, this is a method. We don't need to know anything more about methods other than this is going in, and so you're sending in this, and then outputting the age. And since age already is an int, we know that it's an int and it's going to go here. So now if it is a real int, it will go in here. If not, it will do exactly, we already know what an else is, right?
So what we're doing now is we're nesting an if statement inside of another if statement. And you can get crazy with this.
Yes.
Except for instead of they can't drive, we need to write that's not a number.
That is not a number. Please try again.
All right, let's run that. So let's go back and let's put in 18. Let's do it the
Okay.
right way, right? So we're going to put
18.
18, enter. They can drive, but they can't drink.
Mm-hmm.
End of program. Works just like we would think that it would. This time, we're an alien again, and we've palmed the keyboard. And it says, that's not a number, please try again. End of program. Perfect. So now we've insulated it against user errors, and never underestimate the user. They will, whatever is the wrong thing that you never assumed, they will always do. So,
Yep. I think this is a good place to stop.
I think so.
So we have definitely, to recap, we've covered ifs, comments. We've kind of put a little bit around it, which you don't need to know a lot right now, but know that this is kind of what it looks like. We've talked about read lines and being able to input in.
We started to hint at methods on line 15. We called
A
out.
little bit.
We didn't explain how it works, but we called out an existing method.
Yes.
I guess we've been using the
And if you
console.write
see,
line.
yeah, I was going to say the
We've
same
been using
thing.
that method, but I think they saw that one so early.
Yes,
Yeah.
and so I think this actually you can start building little small programs to give out information or take somebody down a different pathway in a game if you wanted to. But yeah, I hope you enjoyed.